Hey guys, this is Mr. H. Hey, I wanted to go over a concept that a lot of students struggle with starting from first grade to high school and even into college. A lot of students struggle with word problems, math word problems. They hate them. They're not sure how to solve them. So what this video is about is there's three key ideas that I think if you understand these three key ideas, it'll help you a lot when it comes to solving word problems. And the other thing about this is I think there's an idea that most students learn early, like first, second, third grade, that if they leveraged it, it would help them with word problems. So I'm going to go through this. I'm going to go through the three rules, and then I'm going to stop, and then I'm going to follow this up with examples using some Delta Math word problems. All right, so let me go. So the very first thing I want to say is these are numbers. In a sense, these are real numbers in the truest sense of the word real number, right? These are all real numbers: 3, 26.2, 98.6, 112, pi, 0, 18, 3.5. Those are all numbers. But in the sense of word problems, these are not real numbers. They're not real until we put a unit of measurement with them. They're numbers, they're real numbers, they're rational numbers, except for this one. Of course, that's an irrational number, but they're all real numbers technically. But when it comes to word problems, they're not real. They don't become real until you put a unit of measurement with it. Now, if you look here, so instead of just saying 3, if we say 3 kings, now we know, oh, we're talking about kings. So the unit of measurement is kings. If I say 26.2, that's just a number. But when I say 26.2 miles, that means, oh, we're talking about a marathon. And the unit of measurement is miles. If I say 98.6, oh, that's just a number. But when I say 98.6 degrees Fahrenheit, then you guys know, oh, we're talking about the temperature of our human body. And the unit of measurement is degrees Fahrenheit. When I say 100, what does that mean? Is it $100? Is it 100 yards? Well, I said $100, and the reason I said $100 as opposed to 100 yards is this is the only one that I can think of where the unit of measurement comes before the number. Usually, the unit of measurement is the word or the words that follow the number. Right? So if I say 12, that's just a number. But if I say 12 grades, and you guys say, oh, that's the number of grades that you have to complete in order to graduate from high school. If I said pi feet, or if I just said pi is just the ratio. Pi is the ratio of the circumference divided by the diameter, right? That's the ratio. For every circle, that's what pi is. The circumference of the circle divided by the diameter of the circle. That gives you that tells you what pi is. Well, in this case, it's pi feet. So now it's just not some number that's out there. It's a real number. We're measuring it. This one, it's not just 0. If I say 0 degrees Celsius, oh, you would say, oh, that's the temperature that water freezes at when you measure it in Celsius, right? And if I say 18, that's just a number. But when I say 18 years, you know, oh, we're talking about when a person becomes an adult. That's the legal age for an adult, right? So the measurement unit of measurement would be years. And then the last one is just 3.5 zombies. 3.5 is just a rational number, but 3.5 zombies means, wow. That means we have 3 zombies, and then we have half of a zombie, which could happen. Zombies could get cut all up. So let me kind of synthesize this. Whenever you are dealing with a word problem, every number in the word problem has to have a unit of measurement. It has to. They have to tell you what they're measuring these numbers in. Okay, so that's important. Make sure every number must have a unit of measurement. Now, variables too. Now, variables also have to have unit of measurements, like X feet, Y yards, C customers, P dollars for, right? So whatever the variable is, they also have to have a unit of measurement. So let me go back here and say, and variables. So variables and numbers, every number and every variable has to have a unit of measurement. That's the first rule. Okay, now here's the second idea. Now this is the one that we all understand, first grade, second grade, third grade, all the way up to high school. But for some reason, we don't use this idea when we're dealing with word problems. So I'm going to start it this way. On my screen, you can see there's a bunch of fruit. We have some apples, we have some oranges, we have some bananas, and we have more apples. If I were to ask you, how many total apples do you see on my screen? How many do you see? Well, there's 5 apples here. There's 3 oranges here. This has actually 3 bananas. It's kind of hard to see, but there's a third one in the back there, but there's 3 bananas. And there are 3 more apples here. So if I said, how many apples do you have? You would say, oh, we have 5 apples here, and we have 3 apples here. So we can combine those two. So 5 plus 3 equals 8. We have 8 apples all together. Now, my question to you is, how come you didn't include the oranges or bananas in that total? And you guys will say, because they're not apples. Exactly, they're not apples. Another way of saying the same thing is they don't have the same unit of measurement as apples. That's why we can't add them. So now let me try to make this a little cleaner. Now, if I were to change the question and say, how many pieces of fruit do you see? You guys will say, oh, we have 5 pieces here, we have 3 pieces here, we have 3 pieces here, and we have 3 more pieces here, for a total of 14 pieces of fruit. Now, the reason that we can add all of these is the unit of measurement is the same. It's pieces of fruit. It's no longer apples, it's pieces of fruit. So these are all pieces of fruit. They all have the same unit of measurement, so we can now add them together. So whenever you are looking at word problems, you have to look at the unit of measurement, because only things that have the same unit of measurement we can combine. Here's the final example. Again, if I were to say, how many pieces of fruit do you see? There's 5 here, there's 3 here, and there's 3 here. What about this? How come you didn't include those? Because they're not fruit. This would be, let's say, 2 tools. So the unit of measurement is tools. It's not fruit. So we would say, oh, there's 11 pieces of fruit here. And the reason that we would use these is that they all have the same unit of measurement. I hope that makes sense. That's a big idea. Now, so here's the second rule. You can only add or subtract things that have the same unit of measurement. So my first example here, I have 8 apples plus 7 oranges. Is that equal to 15 apples? Absolutely not. We can't say that. We wouldn't say that. We wouldn't say 8 apples plus 7 oranges equals 15 apples. We could say 8 apples plus 7 apples equals 15 apples, or we could say 8 apples plus 7 oranges equals 15 pieces of fruit. But in that case, that means we would have to change this unit, and we'd have to change this unit to fruit. But then that's okay. So they have to have the same unit of measurement in order to add or subtract them. That's the idea that a lot of you always knew, but you don't use it when you're looking at word problems. Now, here's my final rule, and it's kind of related to the one before. I forgot to do this one, so let me get rid of this. All right, so now 2 plus 3, that's equal to 5. 2 plus 3 is also equal to 6 minus 1. 2 plus 3 is also equal to 100 minus 95. So all of these are equal. So that's what makes an equation a true equation is if the numbers on the left total the numbers on the right. And these all work. If I said 94, this wouldn't work anymore. 2 plus 3 is not equal to 100 minus 94. So that no longer would be true. So the numbers have to be, the numbers have to match on the left-hand side of the equation and the right-hand side of the equation. But we're going to go even further. Not only do the numbers need to match, but the units have to match. That's the big idea in this. So this has apples, this has apples, so this has to have apples. Also, this has 8 plus 7, and they have to equal the number over here. So the numbers have to match, the units have to match. So that's the key, okay? Now, if I looked at this last one, I could write something like this, 9 over 3, because 3 over 1 is 3. 9 divided by 3 is 3. Now, but I also know that the units have to be miles on the top and hours on the bottom. I can't do this. I can't say 9 hours over 3 miles. That wouldn't work. It has to be, the numbers have to match and the units have to match. That's the idea. Whenever you have an equation, the left-hand side, the numbers and the units have to match the right-hand side, the numbers and the units. All right? That's it. So let me summarize this. Every number and variable have to have a unit of measurement. They have to. You just got to go find them. Now, this one is the intuition that I'm telling you guys to use. You can only add or subtract those things that have the same unit of measurement. You guys already know that. You already know that. From the first grade, you know that. And then the last thing is that when you have word problems, everything on the left-hand side of the equation, the numbers and the units, have to match what's on the right-hand side of the equation, the numbers and the units. That's the key. When you set up your equations, they have to be balanced. The units have to match and the numbers have to match. All right, so that's the end of this video. I'm going to show you how to use these 3 rules to solve almost any word problem. All right, so, all right, I'm going to sign off and post this.